Hello, everyone. I'm Mads. I design programming languages. There's a new C# every year. We just put one out a couple of months ago. So everything I'm about to tell you is incredibly tentative, okay? Because it's about the next version, and we're actually just sort of figuring out our own plans. But there's a big benefit to talking about it early. It's probably a couple of benefits, but for me, the great benefit is that the earlier we talk about it, the more great input we can get, and course correction we can do, and prioritization, and so on. So please, 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 tell me your thoughts afterwards. Find me, tell me, ask any questions you have, any suggestions you have, because we still have maybe, 8 or 9 months to make changes, and we really do. So one way to do that, I know we can't all have a one-on-one conversation in this room during this hour, but right after the talk, I'll head up to the Microsoft booth on the 5th floor, and I'll hang out there, and I invite you to come and chat, ask questions, whatever you want. Any thoughts you have based on this talk or otherwise, please, please do. This is an information gathering exercise for me as well. But first, the information is going to go in that direction. I'm going to start by taking you to something ugly but useful. So let's see. Let's head to. That was not what I expected to have happen. Let's head. What is that? The magnifier. Okay. Let's head to Bing. And look at, so we designed C# on GitHub, right? And with the participation of the community, of many of you. And that includes features that not only are suggested by people in the community, but that are actually driven, designed, sometimes implemented by people who do not work for Microsoft, but who just love participating in the C# design. So there's 2 GitHub repos. There's the Roslyn repo, which is where the compiler is built, and we track our plans in here. We have this longer and longer list of features that are currently there's implementation work going on with those. So this heading here of working set C#, those are features that there are implementers working on. You can see that's a pretty long list. And we will say hello to pretty much all of this list today, some of them only with a single sentence. And then the broader picture you might get over on the C# Lang repo, which is the repo for the language design. Right? So you have a separate repo. The code over here is documents and stuff. And that's also like where it all happens. And this particular page is where the active proposals can be found in the current state. Some of them are more complete than others. They will probably all change before they make it into the product. But you can see some really interesting stuff here. Or extensions, that sounds great. Dictionary expressions, I want some of those. So, but a lot of the stuff that's in here is not yet being implemented. It may not be headed for a C# version soon, or maybe ever, So just giving you some pointers to where you can find out more after this talk, and giving you an impression of where are the artifacts that we work from when we make C#. Now, I'm going to demo C# 14 for you. I know I told you we haven't implemented it yet, but who's afraid of a little red squiggle? We can still demo it. So I'm going to start with, there's some big features and some small features. And there's one very big feature, and probably the most kind of controversial and interesting, which I'll save kind of for last, because I just want to take you through like the different kinds of things we do in a typical language release, which ranges from like, oh, something it's kind of annoying that you can't do this in C#, or this is a weird restriction, let's remove it. It's like just the paper cut things, all the way up to things we've thought about for multiple years and that are finally kind of coming to a conclusion. So part of our work as language designers is to, try to make sure that there's always something in the hopper for there's always that we always spend some time in a given release working on things that aren't for that release, so that the big things can still happen, even though we're on an every year cycle. I was really worried about that when we went on the every year cycle, but it turns out it's actually not that hard. So here we go. If you have questions along the way, just feel free to yell, or I don't know, there are mics, they might work. Jump up and ask, and if I feel like we're running out of time, I'll I guess cut it off, but feel free to do so. So let's demo some of the small to medium things in C#14, the next C#, essentially by seeing that they are not there yet and lamenting it together. Okay, so we can all go, "Aw." So let's start with one that I think actually is very cool. We added collection expressions. There's an example here of something that works. Collection expressions a couple of versions ago. They're really lovely. Do you also love them? Do you use them a lot? Like who has used a collection expression in here? Yes, right? It's good. Finally, things get less clunky around this. So it was kind of part of the vision all along to also have dictionary expressions, and now we know how we want to do it mostly. There's still some open questions, because isn't it really annoying that as soon as I get to a dictionary, there's no way to create a dictionary with a collection expression, and essentially the thing we're going to add syntactically is we thought about, should there be a completely separate kind of expression for dictionaries, and we're like, no, let's just expand collection expressions, and then there's one more kind of element. Collection expressions have two kinds of elements, right? They have two kinds of things you can have in them. They can have like a single element, or they can have a spread element, which is the ... thing here. And we just add another kind, which is a key value element. We should probably come up with a good name for it, which is I'm associating this key with this value. And you can list those out as well. If you have something that is a key value pair, as the .NET type key value pair, sure, you can pass that, but it's added in a dictionary way. Think of it as using the indexer of the dictionary, indexing with the key and assigning the value. And spread elements as well. Why can't we do that? That would be great. Okay, so that's what we are. That's what we're currently building, and there's some new design questions you have to face other than syntax as well when you're talking about dictionaries. What happens if the same key is used twice in a dictionary expression? Does it blow up? Does the first one win? Does the last one win? You kind of have to decide on these things so people can trust them across all the different dictionary types this is going to support. Let's actually do a vote. Who would like it to clash if you have the same key twice? Okay, wow. Who would like it to have the first one win? Okay, that's pretty clear. Who would like it to have the last one wins? Okay, that's what we do. The last one wins. That's what we decided to do. So it's interesting that so many of you, if some of you can come up to me after and talk me through why that seems right to you. The reason why we chose the last one wins, what was the reason again? No, is that we think the intuition similar to the intuition around collection expressions is that you add the elements. It's true, you can make one by one, like we did with collection initializers. And we think that this add the elements one by one intuition is good, even if it's actually an immutable or read-only dictionary, and they do need to all be added at once. there's still some temporary collection being created behind the scenes where they added one by one. We feel like that has less potential for blowing up code and having bugs that are hard to debug if you just know that the last one's going to win. But maybe we're wrong. So it seems like we're certainly not in alignment with a European audience at this point. Thank you for that. So that's currently being built, and I hope very much that it's going to go in. Does anyone have a question or something on this one? Yes.
As you say, the last one wins. What will happen then? Is will it update the first one, or
yeah, if the last one wins, the way it works is that like all the expressions here still get evaluated. The first one will not necessarily get added to the actual dictionary. There might be a temporary dictionary that gets built up, but in some sense it will be added, right? And then it'll get overridden. That's what happens. And because oftentimes the keys are computed, you don't know. It's hard to keep track of. Has this one already been added? Especially when you're doing a literal and not programmatically building up your dictionary, where are you going to ask the question, has this one already been added, when you're in the middle of just a literal, an expression? So that's kind of why we aimed for that. Yeah. Okay. Was there another one? I'll take two and then move on. Yes.
In Python, it's going to use the curly braces rather than square brackets. Is the syntax fixed in terms of that?
In Python, it's curly brackets, not square brackets. Can we have it more like Python? I'm paraphrasing a little. The syntax is fixed because as soon as we decided that it's better to have dictionary expressions and collection expressions unified into one feature, one of which we already shipped, then it was kind of too late. I will say that when we did collection expressions, curly versus square was a big discussion, and I was on Team Curly for a long time. I think I actually caused the feature to slip by a version because I kept insisting on curly braces, and eventually I realized I was wrong. So there you go. Here are your square brackets. You're welcome. Okay. Now. And I'm sorry if you're in the back and raising your hand. Yeah, you should have come up front. Let's look at some really small features now. Just these things that people are like, oh, this keeps biting me. So Lambda expressions have been around since C#3. I talked about them yesterday. And there's this long form where you give the type and everything, and then there's a short form with or without parentheses. You can still put parentheses if you want, where you omit the types. But what about modifiers on parameters? There are more and more modifiers you can have on. You can have modifiers on Lambda parameters, right? And up until now, it's been the short form has not allowed modifiers either. So if you want, and that means that if you have something like an out parameter, you're essentially forced to always use the long form. If the delegate has an out parameter, you must also put the out the out keyword in the parameter list of the Lambda, and because you must do that, that means now you also must put all the types of all the things, and so you fall off this cliff syntactically. And we're like, why can't we just let you put modifiers in the short form as well? So we're going to just fix that. It's that's what I mean by paper cuts. It's just like fewer places. People will never consider this. Oh, have you heard C# is getting they're getting modifiers in type-less Lambda parameters. Isn't that awesome? It's more like fewer people will go like, oh, that sucks. That's annoying again. So we try to always improve some of those things. And here's another one. So type of in C# you can pass a generic without its type parameters, right? You get something. For name of, when we introduced that, somehow for some reason, we decided that you always had to put a type argument to a generic, which is particularly stupid because the thing you get out of it is a string list without any trace. Those type parameters, there's no way that they can influence the outcome. They're just like the stupid tax that you have to pay every time. Right? It's like the language designers are making me do this over and over and over. Why? So that one we're fixing as well. I'm showing you this in C# 13. I will go and turn on the preview flag in a little bit, and we can see which ones of these are already in preview in the bits I have here, which is a preview version as well. But those are things that will show up, if they aren't already, they will show up in retail bits of .NET in the coming few months, right? And you can play with them too. Null conditional assignment. So we have various kinds of null conditional expressions in C# for a couple of releases now. You have question dot and those kinds of things, where we essentially do things only if the receiver is not null. So you can. So why can't you do that with assignment? Right? Assignment would be pretty useful to say, well, I'm going to assign to this property, but only if C is not null. Like, why do I have to say if C is not null, then do the assignment? That would be useful. Same for like event sign up. So why do these not work? And we're just gonna make them work. Null conditional assignment. We just added partial. So we've had partial methods for a long time. We just added partial properties and partial indexers. But why didn't we add partial events and partial constructors? Well, nobody asked us for them. Didn't get to it. Whatever. So we're just gonna. Now somebody asked us for them. We're like, yeah, that should work. It'll work as well. So those are all like. I think the dictionary expressions is a pretty big one, but the other ones are just like, just for you to get a sense of stuff we also do, so that the nuisances don't accumulate over time, but that hopefully we're keeping them in check. Right? There'll be new nuisances introduced that we will deal with later, but you know, but we have to also like address some top ones of them. So it's not that we have like. It's not that we have telemetry and that we carefully triage which are the most annoying nuisances or to most people or whatever. It's kind of like I think this is cheap to fix, and I heard this a number of times. Let's do that one. Sometimes it's even just like developer preference. Like I want to. For some reason, I'm fired up about this one. Let me go fix it in an afternoon. But here's a thing that I think is more impactful, which is addressing the cliff that we always had with auto properties. So when you have an auto property, the whole point is you don't implement anything. It's just implemented for you. And yes, you can have them with setters or without or with initters, and there are a few things you can tinker with, but by and large, they generate a backing field and they generate the accessors that go into the backing field. And if you don't like it, if you even want to do a little thing, like trim the white space off of a string before you store it on the setter, then you fall off the cliff and you have to declare your own backing field and both accessors, and now your backing field is exposed to all the other members in the class, so that they might accidentally use the backing field instead of the property and get themselves into trouble because something isn't verified, and you know. You fall off the cliff, it's annoying. Can we remove the cliff? And that is indeed what this feature is attempting to do. We're saying you can be an auto property even if you have accessors, in the sense that we will generate a backing field. If you use the new field keyword, we will generate a backing field for you, and you can still have accessors and then interact with that backing field through the field keyword. And it would actually be interesting to see this feature working today. So, and it does. So I'm going to go and and turn on language in preview, and we can play with it for a bit. We can play with that feature, and you can ask questions about it and so on. And then we can go through and see which are the things that are actually already that we have actually already built and that are available in preview. So you can see we dictionary expressions not yet, still being worked on. The lambda parameter thing actually already working. The name of thing already working. Still working on the null conditional thing. Still working on the partials. I think we just had a design meeting about that one a week or two ago. That's still in flux. But hey, so actually this feature is already implemented. When we shipped C# 13, this feature was already implemented, but under the language in preview flag. You saw me change the language. You know about language in preview. That's how we preview language features. It's in the retail bits just behind the flag. So this one you can get out your laptop right now and turn on language in preview and start playing with it if you want. So let's play with this feature a little bit. So field, you see field is now blue, which means it's a keyword, at least right here. C# has many contextual keywords. I think every single blue thing here is a contextual keyword in the curlies here, and none is a true keyword in C#. They're only keywords because of where they occur. That's how we roll. So, but field now designates a backing field. It probably, I don't know, it shouldn't show the compiler-generated name in Visual Studio, but whatever. That refers to the backing field of this property. And I can still, it's an auto property because it has an auto-generated backing field. And if I want, I can still choose to only implement one of the accessors, and the other one still gets auto-implemented to the default behavior, which is, just return what was in the field. So that just works. Now, it's a bit more of a breaking change than we usually have done, and we are interested in how much of a problem that is. What we currently did in the preview bits is, so why is it a breaking change? First of all, let's say that we have a field called field. In C# 13, that would mean that this would bind to that field. That would just be a variable name like any others. And now you can see it's blue, but we give a warning saying, hey, in C#, this changed. In C# 13, this would have referenced the field that is called field. So just beware, like we're giving you a warning as a sign that there's a breaking change happening here. It's not like probably don't all have fields all over the place called field. And many people have different naming conventions and so on. It's not like everyone's going to be hit by this breaking change. But it's also not like inconceivable that there are things out there called field, right? There's a surprising number of fields that use the field word. I just used it in one. And, agriculture and particle physics and, there are lots of fields around. So we're going to go with it, and then we're going to tinker with what's the breaking changes experience. But anything, like if you can try it out, or if you have thoughts on that's the kind of feedback that will also be really useful now, instead of in a year when we've already shipped it and the crap storm is upon us. This is us attempting to push the boundaries a little bit for how we can evolve C#. The more you already have in a language, the harder it is to add new features that don't somehow interact with some code that already exists out there. And we know of a couple of situations in the past where we sort of regret what we did in the name of backwards compatibility. There are some features I like to bring up. Like the original one that everybody knows about is var. maybe you don't know about it, but if you declare a class called var, lowercase v var, then where that is in scope, the var keyword doesn't work. When you say var, it refers to that class instead. So somebody can turn off a language feature by declaring a class somewhere. And there are people who have turned off, people don't like var, I don't like implicit types. So they turn it off for the whole team by sticking a useless class somewhere, and then nobody can use the feature. Like, I've seen it. I'm not joking. I've seen this for real. It's like, that's not how languages should work. That's spooky action at a distance, right? Something over there can make this mean something else. But the one that's probably you can live with that. Nobody has var types anymore, and we even warn on lowercase class names nowadays. But the one I really regret is discards. There are a little underscore that you can use when you need a variable, but you don't care about it. You just need to provide a variable. So it's really useful sometimes. But if somebody declared something called underscore, because underscore is a valid identifier, then it's not a discard. And you can't use discards because that name is taken. And that means that when you use discards, it's something you have to worry about. Is it actually a discard? If you squint, you can see if it's blue or not, but it's just a little line, I guess. It's hard to see those details. So if we had been less worried about saying, okay, sorry, everything named underscore is now a discard, then we would have broken more people, and there would maybe have been a fixer that you could go and change the name of the underscore things to something else, and it would have been it, and the feature would have been much better. So we're thinking to maybe lean into that kind of thing a little more, but I'm interested in your thoughts on it. So this is sort of like the feature that we're going to try to experiment with that approach, with that more bold approach in. Okay. That's it for the smaller features. I have a few more that I want to mention in slides, and then we'll get into something a little more grand. So let's go to PowerPoint. Let's project. So a few more features I just want to mention. First-class spans. Those of you who've been working with spans, they haven't really been fully embraced with the language. The conversions of spans are like user-defined conversions in the libraries, and that causes some problems. It's with extension methods and other interactions. We're just going to make those conversions language conversions. That's also a little bit of a breaking change, but it means that spans work better all over. It's become so popular now that we should probably just embrace them. Compound assignment, when you have user-defined operators and you say plus equals, well, you can override the plus, and then that is being used in the plus equals as well. But sometimes if you have really large types, then it would be better if plus equals could be itself overloaded, because then you could mutate the original value instead of creating a new one. If they're big and expensive, then you can save a lot of allocation and memory and so on. So, for instance, the tensor work that is going on currently with tensors are very big value types. They really want that. So we're going to try to chase being able to declare plus equals separately, and then if you have that, then that's what gets picked instead of using the plus operator for compound assignment. I'm saying the plus operator, but it should work for other operators as well. Faster async, honorable mention. If all goes well, this will not affect the language, but when we did async, it was all a compiler trick. So we rewrite your very beautiful code into a fabulously complicated state machine that we then pass on to the runtime, and it knows nothing about it, which means it just gets some complicated code. It can't know that it's async, so it has a hard time optimizing making assumptions about that'll help it optimize. We throw away too much information. There's a project now in the runtime to implement async directly in the runtime. And then there's that is complicated in and of itself, and then we also have to make it seamlessly work together with the existing implementation of async, which is already out there in compiled code all over the world. We can't tell the whole world to recompile because we changed the implementation of a feature. And so if that all works out in C# 14 or later, then async will just become much faster and much better, because the runtime now can do smart things at runtime with it. But that should, the speed should be the only thing you notice. I bet we will end up having conversations about corner cases that it's hard to make work exactly the same and so on. So there might be slight breaking changes around it, but I hope not. But I think probably a few. So that's the list of small things, and then ta-da! Extension all the things is sort of like the big feature that we're going to start on in C# 14 if we can. Okay. So since time immemorial, you've had extension methods, and that's it. And for as long as they have been there, people have been asking for, okay, so what about extension properties? What if I want to make my extension method static? Actually, extension indexers, can you do that? And we're like, shouldn't be so hard. And then we try, and then we fail. Okay, and we've tried and failed a number of times now. But this time we're going to succeed. And I will show you how. So just to be clear, we are hoping to do this in C# 14, but we have a lot of work ahead of us. We have 1.5 people working full-time on implementing the feature. And we have the design pretty much worked out, though you can all tell me things that will help us adjust. But I don't expect all of this feature to be in C# 14, even if we get something out. I expect that it will be per member kind. Like, we'll implement one kind of member or two kinds of members at a time until, and we may stop at some point when we're like, nobody wants extension constructors, or whatever it is. Like, we might not do all of them ever, but even if we do, it'll be like a trickle out over multiple releases based on what we think is most urgent or easiest to do, okay? So what I'm about to show you is kind of like the full vision of it, but that is almost certainly not what you'll get in C# 14. It's sort of like an end goal. It's proving to ourselves that if we want to go all the way, this approach will work for it. So first, why is it so hard going from extension methods to other kinds of members? What's so hard about it? And essentially, it's because of the way we did extension methods to begin with. This is complicated because they do get complicated. I had to break it in many lines so that the font would be big enough so you can see it in the back. And this is one of the existing extension methods. It's a select method, right? But if you look at it, it has some elements that are about it being an extension method, and some elements that are about how it works when it's called as an instance member. You can kind of separate them into two parts, right? These are the things that are about, oh, I'm an extension method on that type, right? I'm saying IEnumerable of t source for some t source, that's a type argument for that purpose. That's what I'm an extension on, and the rest of it really is, if you remove that stuff and let's yank it out into a comment, all that extension method specific stuff, then what's left is really an instance method that looks like the method you think you're calling when you call it as an extension method, right? It's the method it's pretending to be. That's the remaining stuff there. And so so that suggests a good approach, right? If we can find a way to specify the extension stuff separately, and then this approach generalizes to, okay, that just looks like an instance method. Then I guess an extension property should just look like an instance property. Then I guess an extension operator overload should just look like an operator overload. Like, we can essentially, as long as we can isolate the strange stuff, then it's easy to say, well, it looks just the same as if you were writing it in the class itself, at least as far as the signature of it is concerned, right? So that makes it much easier to understand how extension methods work, and it kind of extension members work, and it applies orthogonally to all member kinds. It's just a little question of, so we can explore that a bit, just like assuming that we find some way of doing the stuff in the comment, like here's an extension property, here's an extension indexer. It just looks like the thing it is, right? An extension index is just an indexer, where somebody else somewhere said where it's going to go, what it's going to apply to. Extension static members would be really useful too. So it's just that little, now it's just that little syntactic matter of, well, how and where do you say that extension stuff? And we felt we were left with two options, neither of which were really appealing. And we had wars about it on the design team, to be honest, because, well, not wars, so we were all still alive, but because it was easy to see the problems with the other approach. And in the end, we were like, okay, we should actually take seriously that both of these have problems, and maybe there's a third option. Of course, it was someone from the community who suggested the third option. And so eventually, just kind of previewing what we're going to go through here, eventually we picked like the surprising middle ground that emerged. And it may take a little squinting to get used to, but the more I've been playing with it over the last couple of months, the more I like it myself. So that's at least probably a sign that I'm, I don't know, living in an echo chamber or something. Or maybe that is a quite good idea. So first approach is to stick the extension stuff on each member. So that's a bit like, philosophically, it's like what we do today. Every extension member has all the extension stuff for it on it, inside of the static class. So we could just say, put some syntax like this extension, whatever type parameters we need for the underlying type itself as a parameter, just like in extension methods today, and then followed by the full member declaration. And I don't know what you think, but and we could squibble about exactly how that should be all arranged, but it kind of feels, it's a big mouthful, and it's a while. You have to read quite far to see where the actual member starts, and like, oh, 120 characters over, oh, it was an extension indexer. I get it now. And it's sort of like a preamble, like an attribute. Is it really, does it seem right that it goes before even the modifiers, or but if it goes after the modifiers, then I don't know. And there's a lot of angle brackets and parens that kind of might get jumbled up with all the angle brackets and parens in the member itself and so on. So this feels heavy, feels impenetrable. And the other option is to go the other way and say, hey, let's somehow put it at the type declaration level. Okay, so let's instead of just having a static class wrapping it all, let's have type level declarations for each underlying type. Okay, so we say actually this, now we move away from the paradigm of having them in static classes. We say there are new kinds of type declarations. They're extension declarations. They each have their own name. And they are then where you say, oh, this is an extension on non-generic enumerable. This is an extension on generic enumerable. And then all the members in there are for that. Okay, so that's more appealing in a sense. You get a separation between the extension stuff and the member stuff. That's visible and nice, but it still gets difficult. There are many things about it that aren't so great. Maybe if we were starting from scratch now, doing extension members all over, this would be fine. Even though once we tried applying it to real-world scenarios and our, for instance, system.link.enumerable, which that one has 14, I think 14 different underlying types. There are extension methods for 14 different receiver types in that. So that would mean we would have to create 14 separate extension declarations, come up with a name for each. Oh, here's int enumerable, here's a key value pair enumerable, and those kinds of things. And it would also mean actually that we would lose the connection to the current extension methods, both in terms of kind of like mental model, but also we would lose all hope of there being a compatible path to move from the old syntax to the new. This would have different semantics, even just from living in declarations that have different names from the ones they have today. And so people would have to keep their old extension methods around forever or break their consumers. So that ended up also being an important argument against it. So it's not just the syntax in and of itself, but it's also in context of what's already there, and both in terms of code and mental model. So both kind of suck. And then his name is Joseph, said, well, can we just add an extra layer? If it shouldn't go up there and if it shouldn't go in here, can we just like put something in the middle? And that's what we're going to do. So essentially, we stay in static classes. They can be all the other usual things in the static classes, even your old extension methods if you want. But there's a new kind of declaration you can have in a static class, and that's an extension declaration. And it's anonymous. It's just the extension keyword, any type parameters it needs, and then this parameter. And then inside of it, then you can, a level separated from all that gunk, that's where you can then declare your members with instance syntax, or with the usual syntax from when they're just declared in normal classes. Okay, make sense? So if pushing it up is too far, if pushing it down is too far, put it in the middle. And I know it introduces an extra nesting level, and sometimes that might be annoying, but we do have the option. We may not do it out of the gate, but we have the option of saying, okay, it seems that people get annoyed when they only have one underlying type for all the extension members in a given, like they get annoyed about having to have that extra layer anyway. Well, maybe we can give you a shorthand for removing the layer in those cases. Or the other way around, I have a bunch of extension members that are the only extension member for their given type. Like you see that as well sometimes. Well, maybe there's a shorthand for then pushing it down, getting rid of the curlies and pushing it down onto that member. So we have that option later if we want to, but the general case, I think, works. What do you think? You think, 2 thumbs up. If you love it, raise your hand. Okay. If you hate it, raise your hand. Okay, let's talk afterwards. The dissenter is always, this is a language design meeting secret. The dissenter is always the most interesting person in the room. We very much encourage our language design team to dissent, and whenever we have a raise of hand like this, we call it a read of the room, because it's not a formal vote, and somebody's like, especially if they haven't spoken up in the meeting yet, and they're like, I want something else, if it's 1 or 2, and it's like, awesome, maybe there's something we haven't thought about. Please tell us more. So please tell me more when we get there. Yeah, this is a general approach that we're going with. That's still not the whole design. I've just been showing you ... for all the bodies so far, because there's a lot of code to have on screen. Now let's talk about the bodies of extension members. So those were we have these groupings here, and then we have extension members inside, and then can be, in principle, any member kind, as long as they're not instance members with state. So we can't have instance fields, extension instance fields, because who creates them and where do they live and stuff. But other than that, now what happens in the bodies? Here is another discussion. What we went with is continuity from current extension methods. The underlying type, the receiver, is specified as a parameter. We kept that from when it really was a parameter in a static method. So it has the same intuition. It also means that if there are any extra annotations, a ref modifier, an attribute, a nullable annotation, something like that, there are natural places to put it because it's a parameter. And so what we decided is that just like current extension methods, the way you refer to the receiver is with that parameter name. Okay, so and that's probably not surprising if you're used to writing extension methods. So it's called source, and I refer to it as source. And you see source. Just that's how we refer to the receiver. But there was a school of thought that I was certainly part of for a while, which is, well, since the member signatures look exactly like they do in a class, shouldn't the body also look like it would be in a class? And when you're in a class, you refer to the receiver with this keyword. And in fact, you can even omit it and just, refer to your neighboring members as a simple name. Instead of saying this dot method, you can just say method. Shouldn't we preserve that also and have that consistency? And essentially, it comes down to, like, one way of thinking of it is, it comes down to, do I want to be able to copy-paste from existing extension methods to new extension members, or do I want to be able to copy-paste from existing instance members to extension members? Right? Which consistency is more important? And at the end of the day, we went with consistency with existing extension methods. This again helps us. It's just a mental model, and you just have to pick one. But it also helps us with the actual coexistence of those two features. It helps this be a full heir, if you will, to the old feature. It makes it so that we can let you compatibly migrate all of your old extension methods into this new syntax, so that without them breaking their consumers, instead of you having to leave them behind and not be able to commingle with their new extension property kind of family members, right? So this way, you can take your existing extensions, move them into a new syntax if you want to, add other extension members with them, and it all kind of sits in one place using the new syntax, and no existing customer gets upset. So it feels like the best compromise for us. But I'm just trying to give you all the trade-offs as we've had them, so you understand why we arrived at this, and so that when you give me feedback that there's something we're not thinking about or that we were thinking about wrong, then you get to start from that level, so to speak. Right? Yes?
The third line, couldn't you write extension enumerable this?
Couldn't you, like, are you asking, in this design, could a user just do that?
If I wrote this instead of source,
Mm-hmm.
I would expect everything to work just like if it was a plain method. I could write this .any.
Yeah. So essentially, could you just use this as the parameter name and then there would be this inside as well? With the current design, no, because this is a keyword in C#. But you could write @this, where is the thing that quotes. We
Just to have the two
just
worlds, the best of.
to have the best of the two worlds. We could potentially allow something like that. We talked about allowing that on top, like also allowing you to use this. But let's see if this doesn't do the trick. And then if it turns out that that people have good reason, like there's a lot of people like, can I just write this? Then maybe we will introduce an alternative syntax for it. But I don't want to introduce two ways of doing the same thing out of the gate. Sometimes you end up with two ways of doing a thing, but it should be because one came up later that was better, or like so. Yeah, that kind of thing is on the radar a little bit, that we have options of doing something like that. So yeah, good point. Okay. That's extensions. Let's take one more question.
What happens if you create an extension method and then one version up, the same method is now in the main body or pre-exists?
Great question. What happens if you create an extension method or member, and then in a later release of the type you're extending, that type itself gets a member that shadows it, really? Well, the same thing happens as with extension methods today. And that brings me to a thing that I should mention, which is today extension methods are also static methods. And that means if somebody in a later version shadows them, at least there's another syntax that you can still call the extension method with. You can just not call it as an extension method, but as the static method it also is. It does break. So an extension method can always be overridden by something coming in on the underlying type. And that problem will persist with this design as well. The important thing is, well, and maybe that is unfortunate in itself, but what helps is if there's a way for you to still refer to the original extension method. And so that's ongoing for us to try to decide what's the best, we call it disambiguation syntax, but it's not really just for disambiguation. What's the best syntax for saying, even though it's hidden, get me that extension member? And the challenge with designing that, the reason why it's not just straightforward, is that we can't just call the static method when you haven't declared it as a static method. No. But also, what if it's an extension operator or an extension constructor? How do you call that directly? What is the syntax for that? So we have to come up with just like we came up with a syntax for declaration that's independent, that works independently of the member kind. We have to come up with a syntax for disambiguation that works independently of the member kind. And it's certainly possible. We have many candidates that satisfy that. But they kind of poke us in the eyes. We don't love any of them. So that's an ongoing thing. So thanks for pointing that out. It's definitely our intention that there is a way to pick an extension method that isn't otherwise the thing that is picked, or that is ambiguous with another extension method, or whatever it might be. We just haven't landed that part of the design yet. So any ideas there are also, come and tell me, please, if you have a good idea there. Thank you. Okay, I have one more topic, that I'm going to touch on just briefly. So let's look at, we've seen some examples of extension member kinds. You could also imagine actually extension constructors. And I think it would be kind of cool, but extension constructors are probably the one thing that would look different than its instance member cousin. Because in an instance member, a constructor is part of it calls its base constructors, and it's part of this whole process that when you get to the body of the constructor, the object has already been created. And we think that is hard to make right. We think extension constructors, if we do them, should be more like a fancy static factory. So the signature of it would still look like a constructor, but you don't get to call base or anything. You don't get to have base of this calls. Instead, you get a method body where you actually create the object and return it. That feels better. Then you can create an object of the underlying type using one of the underlying types, constructors, or a factory method for it, or whatever you like. Then you get to choose the means of construction. You can tinker with it whichever way you like and then return it. That seems better than trying to squeeze it into what constructors do. But the benefit of it would still be that your users can then use the new keyword to create the object in a way that they couldn't on the underlying type, right? So you're adding the right surface area, but the means of implementation is different. Okay. Another thing, extension operators. I mentioned the tensor people before. They really want this as well. They want, and you think about it, think about a matrix type. Sometimes you can do math on the elements in a matrix, and sometimes there's something else. But wouldn't it be neat that if you could do math, if the element type is one that you can do math on, then you can also do math on the matrices, right? Having that kind of declaration. Well, an extension operator could do that because it could, this one doesn't, but it could apply to IEnumerable of t where t colon I number, like the math interfaces. So if the underlying type, or where the underlying type supports adding and multiplying, for instance, you could specify that, then this extension method applies, and you can also add and multiply the matrices, or whatever math you want to do on them. So it gives this way of properties, of element types properties, to bubble up to the surface area of a compound type in neat ways. And this is just like a simple example of that, where if it happens to be an IEnumerable of int, then it has a plus operator where you can add an int, and it adds to all the elements, right? Just as a trivial example of that. And speaking of operators, should we allow user-defined conversion operators? Like, this is one of those that might be controversial, just because user-defined conversions are controversial in general, because it can be a bit unpredictable what happens in code when there are these extra conversions that might apply. Could it all of a sudden make existing calls ambiguous if there's a new conversion that comes in, and that kind of stuff? So maybe we shouldn't do it, but on the other hand, sometimes it might be useful. So scenarios or dangers, we'd love to hear about them. We'll probably not do this in C#14, but it will be on the table at some point, and we'll have to decide, do the dangers outweigh the benefits, that kind of stuff. But if we want it, we can do it. Okay, 2 minutes left. Let's talk about unions. So we're not going to do unions in C#14. We still don't know how to do them. What are unions even? People disagree on this point even. So functional programmers have something like this, and that's what they have instead of object-oriented inheritance. They're like, I have a type called U, and it can be either an A or a B, okay? But it can be nothing else. So it's kind of a closed list. It's exhaustive, and then they do the fancy pattern matching, and they know that when they check for A and they check for B, they don't have to complain about you not having checked all the things. It's exhaustive. And that's a really useful thing that we don't have with inheritance, so maybe we should have that. And then they also have fancy short syntax, and maybe fancy short syntax is also cool. So those are the two benefits we might get from functional style unions. And then you can create an A, and it's a U, and we could merge it with object-oriented programming by having this mean inheritance, like A inherits from U, and you could even maybe add members and stuff as well. But we also guarantee the exhaustiveness and give you the neat thing. Maybe there's a struct version that is more efficient. That's the case for records, so maybe we could do that for unions as well. But it has problems, so maybe not. There's also a completely different approach to unions, which some of you might know from TypeScript, which is that a union is not like a separate type you declare. It's just something you can create from other types whenever you need it. This right here, this argument, this local variable is an A or a B, and that's just you create the union types on the fly. Or maybe there's something in between where you declare the unions, but instead of A and B being new things, you also you can declare a union between two existing A and B types. We may do any, all, or none of these. We're exploring. Currently, we're like, this one here is the most feasible, the union classes. It's the one that we think we know how to solve all the technical problems, because that's what F# already does and how it compiles it, so we can steal. So we're exploring the details of that design, and we may go do it. At the same time, we want to also keep thinking about the technical problems that the other ones have, and eventually, one day, we will pick a winner and we'll do it, or do a couple of them if they fit nicely together. We're on this journey. We're making progress. It's going to take a while. I'm always very interested in your thoughts. So even though I don't have a lot to show, I'm putting it here at the end just to please ask you if you have thoughts. Come and find me and tell me. And that's a good way to end the talk. Again, I will walk up to the Microsoft booth on level 5 right after the talk. Come and chat with me there, or hunt me down at another time during the rest of the conference, because I know you all have thoughts, and I want to hear them. Thank you all. Have a great rest of the conference.